Okay, today we're going to learn two very important formulas. One is called the distance formula, one is called the midpoint formula. And the distance formula, the derivation of that, actually comes from the Pythagorean theorem, which we've just learned about. Okay, so let's say I want to find the length of a segment on a coordinate plane. I'm going to use something called the distance formula. Now, I'm going to explain how the distance formula comes about, and then after I do this whole explanation, you're just going to, after that, you'll just use the formula. So let's for the moment feel that you don't know the distance formula, and you're trying to find the distance between points A and B. And I've given you the coordinates of point A and point B. It's 1, 2, and 5, 5. So we could, if we wanted to, create a little triangle. You're not going to need to do this for every problem. This is just to show you where the distance formula comes from. I could create a right triangle where AB, that segment AB, is actually the hypotenuse of my right triangle. So here's my right angle. Let's call this point C if we want. If we wanted to figure out what the length of BC is, well, an easy way could just be to count. And we know that it goes from this point C is 5, 2, right? So we could count the distance between 2, this 2 and this 5. This distance is 3. 5 minus 2 is 3. Then if we want to find this, we could also count. We could say it's 1, 2, 3, 4, or we can just take the coordinates, this 5 right here, and subtract 1, the x-coordinates, and we know that that distance right there is 4. So we basically have a triangle that has a side of 3 and a side of 4, the two legs, and we're asking what is the length of the hypotenuse. Well, in the last lesson we learned the Pythagorean theorem, which would say that 3 squared plus 4 squared should equal, we'll call this n squared. So if we calculate this out, we get 9 plus 16 equals n squared. We get 25 equals n squared. And if we take the square root of both sides, we'll get n equals 5. So that's sort of a long way of doing this problem. You're not going to need to draw triangles for every time I give you 2 points on a coordinate plane. Instead, you're going to use a distance formula. Okay, so if we want to find the distance, we're going to use the distance formula, the distance between 2 points with these coordinates. I know these coordinates look funny because they have numbers on them, x1, y1, and x2, y2. So those numbers down below are actually called subscripts. They're not exponents. They're simply labels. They're ways to label points. So if I had a third point, I could call it x3, y3. If I had a fourth point, I could call it x4, y4. You'll see why I'm going to do that in just a second. So I'm going to say that the distance between x1, y1 and x2, y2 is this formula. And this is the one that you'll need to know. You're going to take the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we remember, I'll probably spend some time in class showing you where this comes from, but for right now, I think I would prefer that we just use this formula. It's a little bit easier to explain in person why this formula is what it is. It does come from that Pythagorean theorem example that we just did. So let's say we have a point here and here, can be anywhere on the coordinate plane. If this is point x1, y1, and this is point x2, y2, again those are just labels called subscripts, then the distance between them, I would take what those coordinates are and I would plug it into this formula. This formula is key. This is the one you need to have in your memory. Yes, you will need to memorize it. It's not so complicated. Once you actually use it for working out problems, it'll start, you'll be able to remember it. Okay, I rewrote the distance formula at the top of the page, and you should write it at the top of your homework page as well. And the first example is find the distance between these 2 points, 8, 4, and -6, -2. You actually don't need to draw the picture. Let me show you where the x1, y1, x2, y2 comes into here. This coordinate right here, we can call, it doesn't matter which one we call which, but I'm going to just call this x1, y1. And I'm going to call this one x2, y2. In other words, I'm just going to plug in these numbers for those variables in the formula. So the distance between those 2 points is, and now here's where I plug in the formula, x2 minus x1. So here's my x2, here's my x1. So it's going to be negative 6 minus 8, that quantity squared. All I did was I plugged in negative 6 for x2 and 8 for x1, plus, let's extend this square root a little bit, plus y2 minus y1. So it's negative 2 minus 4, that quantity squared. All I did was plug in the values. I could have called either point x1, y1 and the other one x2, y2. I just chose to do it that way. So now I have to calculate this. So negative 6 minus 8 is negative 14. So it's negative 14 squared. Negative 2 minus 4 is negative 6 squared. So I end up with, and if you don't know what negative 14 squared is, just square 14, or negative times negative will be positive, you'll get 196. So you have 196 plus 36. This is both under the square root. You have to calculate what's under the square root first. You can't take the square root of two separate terms. So you get the square root of 232. If you were to use, you can leave your answer like that, or if you can, if the book asks you to use a calculator, then go for it, use a calculator. That's approximately 15.2. So the distance between those 2 points is approximately, notice I used the approximately equal symbol, approximately 15.2. Okay, so now let's try another example. Let's try to find the distance between negative 3, 1 and 2, negative 4. So if you remember your distance formula, and again, I can call either one x1, y1 and either one x2, y2. So let's call this one x1, y1, and we'll call this one x2, y2. You realize I could have called them, the points A, B, A comma B, and C comma D, but we do it this way just to make it conforming. So we have the distance equals, so we're going to do x2 minus x1 and take that and square it. So we have 2 minus negative 3 squared. Remember that the negative on the 3 is not replace the minus sign between the two numbers. It just is in addition to it. Plus y2 minus y1, so that's negative 4 minus 1, that quantity squared. So that equals 2 plus 3 squared plus negative 4 minus 1 is negative 5 squared. So here we have 5 squared plus negative 5 squared. That's going to equal 25 plus 25, which is the square root of 50. And if you're asked to get an approximation, you can use your calculator, and that's approximately 7.1. So the distance between those 2 points is approximately 7.1. On the test, we're not going to be using calculators, so I would allow you to keep your answer like that. Okay, on a line segment, the point halfway between the two endpoints is called the midpoint. Kind of makes sense, right? To find the coordinates of that midpoint, you use something called the midpoint formula, which we're going to talk about in a second. So in this picture, AB is the segment, A and B are each the endpoints. These guys are the endpoints. And M is the midpoint of AB. And the way that I've shown that is by drawing these little, what I call like tick marks or hash marks. Those show that those two segments from A to M and from M to B are congruent or of the same measure. Okay, so the midpoint formula says if you want to find the midpoint of a segment with endpoints at x1, y1 and x2, y2, just again labels of points, we're going to use something that's like finding an average. For instance, if you have two test grades, 85 and 92, and you want to find your average, you add those two numbers and you divide by 2. You're going to do the same thing to find the midpoint. So the midpoint of that line segment would be you take the average of the x-coordinates, x1 plus x2 over 2, that's the new x-coordinate of the midpoint, comma, y1 plus y2 over 2. And again, this is the second important formula here. This is the one you need to memorize. This is actually not hard at all to use. Let's do an example. Okay, the first example is find the midpoint of the segment with endpoints 4, 6, and negative 8, negative 12. You actually don't need to draw it. If you want to draw it at the end to check to see if your answer seems reasonable, then that's fine. But all we need to do is plug it into the formula. I'm going to call the first point x1, y1, and the second point x2, y2. Again, it doesn't matter which one I call which. You just choose one and go with it. Sorry, I forgot the comma here. Okay, so we're going to plug in, so to find the midpoint of that, we're just going to plug them in. x1 plus x2. So here's x1, and here's x2. So we've got 4 plus negative 8, that whole thing over 2, comma, and now we're going to add the y coordinates. The y1 is negative 6, and the y2 is negative 12. So 6 plus negative 12 over 2. And then we simplify. 4 plus negative 8 is negative 4 over 2. 6 plus negative 12 is negative 6 over 2. And again, just simplify further, and we get negative 2, comma, negative 3. That is the midpoint of the segment. So all we did was we found the average of the x-coordinates and the average of the y-coordinates. Okay, why don't you try this problem and then pause the video, try it, and then turn the video back on and check your answer. This one is find the coordinates of the midpoint of a segment with endpoints negative 6, 7, and 2, negative 3. Go ahead and pause the video, try the problem, and then turn it back on. So I'm going to call the first one x1, y1, and I'm going to call the second one x2, y2. That's just so I can know what numbers to plug in. And the midpoint, again, I'm just finding the average of the x-coordinates. So negative 6 plus 2 all over 2, just like you would find the average of 2 test grades. And then I'm going to take the average of the y-coordinates, 7 plus negative 3 over 2. So that becomes negative 4 over 2. 7 plus negative 3 is 4 over 2. So we end up with negative 2, comma 2. That is the coordinate, those are the coordinates of the midpoint. Okay, here's a challenge type problem. If one endpoint of a segment has coordinates 2, 3, and the midpoint has coordinates 7, 8, find the coordinates of the other endpoint of the segment. So basically what this problem is it looks like this. I'm not going to draw it sort of to scale. I'm just going to draw a point. We'll call A and B the endpoints. And we'll say that A has the coordinates 2, 3. And then there's a midpoint, call it M, and the midpoint's coordinates are 7, 8. And what we're looking for are the coordinates of B. B is something, comma, something. You can call it X, comma, Y if you want. And that's what you're looking for. So if we want to use that midpoint formula, remember the midpoint formula that we just learned, we're going to take the average of the endpoints, the coordinates of the endpoints, to find the midpoint. So we already know the midpoint. The thing we don't know is one of the endpoints. So you could say that let's work on each one separately. The x-coordinate, 7, the x-coordinate of the midpoint, is the average of the 2 endpoints. So we've got 2, that's this endpoint, x-coordinate, and we don't know this one. So it's 2 plus x over 2. We also know that the y-coordinate has to be the average of the 2 y-coordinates, 3 and y. So that's going to be 3 plus y over 2. Now you've got 2 ratios, or proportion, 2 ratios set equal to each other. You could cross multiply, for instance, right? And remember, these two constitute an entire chunk. So 7 times 2 is 14. That equals 2 plus x. To solve that, we're going to subtract 2 from both sides, and we get x equals 12. Doing the same thing over here. Cross multiply, we get 8 times 2 is 16. 3 plus y times 1 is 3 plus y. We're now going to subtract 3, and we get y equals 13. So we now have the coordinates of the other endpoint. The other endpoint, point B, is 12, comma 13. You can check it by adding 2 plus 12, dividing by 2, and hopefully you get 7, etc.